basically is around is no wind, let's say. Okay, so then you can roughly have some idea already. Okay, this machine is located outside, no wind, so meaning it's not a forced convection, but it's a free convection. Then so you roughly have some idea. Okay, if free convection under this kind of situation, maybe the value is around 10 watt per meter square per Kelvin. Yeah. Okay, so or you want to estimate, let's say it's a range. Okay, under this kind of natural convection situation, what would be the maximum possible H value? What would be the minimum possible H value? Then if you have this value in your mind, then it's very easy for you to just take out your handphone, then just calculate. Okay, so that is the reason why we because all these are quite common: air, water, right, steam, especially air and water. So as engineer, quite often we deal with this kind of environment, right? So that's why we want you to have some idea, right? Or if it's free convection, then the H value is around 2 to 25, not more than that, right? So when you at least you try to calculate, estimate, then you know, oh, what is the value should I take? Okay, so this is the reason. Okay, and next time in the future, anything you take from, let's say you refer to any resource as your reference, I want you to have this kind of habit, so to give the source of your reference. Okay, so this is my comment. Basically, I think these are all okay lah, because you take it from some source of reference, right? So to me, this value are okay. Okay. So that is activity 2-1. It's just the beginning. So activity 2-2. Okay, for activity 2-2. Basically, why we give you this activity is so that you prepare a list of equation for yourself to ease yourself when you try to solve some problem after this. Okay, so with this list, first you prepare it for yourself, so along the way you also learn, right? Then this list is going to be very helpful after this when you try to solve different types of question. Okay, so you know, basically, if you see this list, yeah, there are two types of main condition. Two types of main condition. Okay, what are the two types of main condition? Type in the chat box. There are two major types of condition. What, based on this list, two major types of condition. What are the two types of condition? Everyone type in the chat box. Laminar and turbulent. Unfortunately, that's not the answer. Not laminar and turbulent, no. Try to think. Fully develop an entrance, no. Good try. Keep trying, keep trying. Fluid and liquid metal, no. Try. Hey, come on. Try to think. Okay? Jangan main type je. Inside and outside pipe. Almost there, Shafiq. Almost there. Inside pipe and outside geometries. %90. Any other? Please don't try privately ya. Jangan takut salah. Type your answer in the chat box to everyone. Okay? Don't be afraid of making mistake. It's not a problem. If you make mistake, you can make mistake now, but please don't make mistake during test. Just now there is one answer which is very close already. Movement fluid or air inside pipe and outside pipe. Ya, lebih kurang lah. Okay, so the answer is, you see this list on the top, right? Forced convection, fluid inside pipe, right? So we have first situation, internal flow, right? Fluid inside, normally in industry lah, for our case as chemical engineer, we deal with many fluids flowing inside pipe, right? If you visit a chemical plant, you will see you will see their very complicated piping system, right? So the first situation we deal with is fluid flowing inside pipes. We call that internal flow. Okay, then here, second page, you see fluid flow outside geometries. What does it mean by geometry? So basically there are two situations. One is internal flow, one is external flow. Okay, internal flow and external flow. I think the most common type is type number 1, internal flow. But external flow is also quite common. Yeah. Okay, so these are the two major classes of flow. So you can, let's say if you want to come up with a mind map, right? Then there are two major categories. One is internal flow, one is external flow, right? So if internal flow, then you need to go back to what you learned in fluid mechanics, right? Reynolds number, because types of flow actually depends on Reynolds number. There are 3 types of flow, right? What are the 3 types of flow? Type in the chat box. Okay, correct. Laminar, turbulent, and transition. Okay, laminar, turbulent, and transition. So here you see 3 types of flow: laminar, turbulent, and transition. Transition is basically the flow start to get it is something like, sometimes it is turbulent, it flows very vigorously, sometimes it's still flow, then you can see the stream profile, something like that, right? So that's laminar. So sometimes laminar, sometimes turbulent, something like that in between. So that's why they call it as transition region. Okay, transition from laminar to turbulent. That's why it's called transition. But what is the preferable flow type? Which one? Which one is more preferable in industry? Or which one is preferable for heat transfer? Yeah. Which one? Okay, Hassan, you say turbulent. Unmute yourself. Why?
It is because when it is turbulent, then the heat will easily to discharge.
Easily what?
Easily to discharge from the thing, from the
Discharge.
liquid. Yeah, yeah.
What do you mean by discharge?
Dia macam bila turbulent ni dia akan berorak lah dia punya ni, jadi dia punya haba senang keluar. Tak sehari.
Senang keluar. Senang keluar
Ah.
dari mana? Dari pipe?
Ya, dari pipe.
Kenapa nak senang keluar dari pipe?
Macam untuk heat, kalau yang flow tu akan ada heat, dia akan lagi itulah cepat sikit untuk elak kerosakan.
Is this what you learn in fluid mechanics?
I just read it when I do this.
Okay, thank you.
Yeah.
In my opinion, yes, most of the time for heat transfer, if you consider heat transfer, turbulent is preferable. Why? Because in turbulent flow, you see the flow that mix very well, right? So this actually helps a lot in increasing the heat transfer. Okay, so that's why I say from the perspective of heat transfer, actually turbulent flow is preferable. Okay, turbulent flow is preferable. So you will see if the flow is turbulent, then the H value, heat transfer coefficient will be higher. Okay, that's the reason. Okay, what else? Okay, there is one more thing I want to highlight here. You see, for flow outside pipe, fluid properties is taken. You see this. The fluid properties is taken at TB average. Okay, T bulk average. Okay, what is TB average? Okay, this is very important because you see, for fluid properties, what does it mean by fluid properties? If you want to calculate, let me take laminar flow as example, yeah. Okay, so let's say you have this pipe. Right, you have this pipe, then water flow in and flow out. Okay, then let's say this is 5 meter. The length is 5 meter. Okay, when it enters, the temperature T in is 30. When it flows out, the temperature is 60. T out is 60 degrees Celsius. Okay. So here you need to use when you calculate let's say Reynolds number. We know Reynolds number. The formula is rho V D over. Sorry, this rho over mu. Okay. V, okay, rho V D. D is diameter, rho is the density of the water, V is the velocity of the water, okay, and mu is viscosity, right? So all these are actually physical properties of water, right? Then all this depends on temperature, right? Rho depends on temperature, mu also depends on temperature, right? So, but the problem is, you see, there are two temperatures here. It enters at 30, it exits at 60. Then which temperature to take? You want to refer to rho at which temperature? So the scientists, they come out with a solution. Okay, so they decide that since we have a big difference, right? So the physical properties will be taken at TB average. TB average means T bulk average, right? Average, it means it's an arithmetic average. It means equals to what? Equals to T in plus T out divided by 2. Then this will be your TB average. So in this case is what? Your TB average equals to 45 degrees Celsius. Okay, so when you calculate, when you search for the table, right, the value of rho, the value of mu, then you will take it as the value of mu and rho at 45 degrees Celsius. Okay, this is the meaning. Okay, so for flow inside pipe, internal flow, your fluid properties will be taken at TB average. Okay, but you see here at page 2, for external flow, okay, fluid properties taken at TF. What is TF? Anyone can tell me what is TF? Just unmute yourself. TF means T film. Okay, what is T film? You see the situation now. Let's say I have a plate. Okay, I have a plate. Okay, so wind flow, air flow through the surface of the plate. Okay, flow through the surface of the plate. Let's say the plate surface temperature is 100 degrees Celsius, right? And this air is ambient air, so it's 25 degrees Celsius, let's say. Okay, then now you want to calculate, let's say this one. You also need to calculate Reynolds number, Prandtl number, and all this also require you to say Reynolds number equals to what? Rho B, in this case L, okay, not D, over mu. Then you see rho and mu also depends on temperature. And now you have two temperature. So which temperature to take? So since now it is not internal flow, it is an external flow, so they give a new name to the temperature. It's called T film. What is T film? Okay, so because this plate has thickness, right? Something like this, So if I take a look here, okay, from this perspective, front view, okay, engineering drawing, front view, okay, it looks like this, right? It looks like this, right? So air flow here, okay, so T air is 25. Ts of the plate is 100, right? So when this air flow past the plate surface, what will happen is it will form a layer of so-called film here, because this surface is hot, right? So the air flow past this surface will be heated up, right? So there is a layer, thin layer of air, heated air here. So this layer is called, there is a film, right? Yeah, so that's why scientists give a name to this temperature, okay? So because now the surface we are interested is this surface, right? Because you know Q for your convection is A, surface area, H, delta T, right? So this surface, this is the surface, right? This is the A, and this surface, on this surface there will be a film, right? There will be a film. So this temperature is called, the temperature of this layer of film is called TF, T film. Okay, and what is the formula for T film? Is actually similar to the T-bar average, TB average. Okay, for the case of internal flow, that is T surface of the plate, in this case lah, T surface or T wall. Normally people call that T wall. Okay, because it's surface, right? TW plus T T-bulk of fluid. In this case, it's air, right? Sometimes it can be water, right? Or any other type of fluid, divided by 2. Okay, so is this temperature you need to take when you refer to the table to get the value of your rho and your mu and any other physical properties. Okay, so in this case, what is the TF? What is the TF for this case? What is the TF for this case?
62.5 degrees Celsius.
Yes, 100 plus 25 divided by 2. So 62.5 degrees Celsius. Okay, so I hope you got it. And there is one, important thing. I want you to refer to this formula for plate. Okay, and I have a question for you. Okay, no space. Okay. Let's say I have a plate like this. Okay, I have a plate like this. Here is 1 meter. This is 3 meter. Air flow like this. Okay. For this case, what is the value of your L? Because you see here, Nusselt number, you have HL, right? Okay, L is the length. Tell me, for this case, what is the value of L? Type in the chat box now. Type in the chat box. What is the value of L? It's okay, you just type. Don't be afraid of making mistake. Just type. I don't want private message. Type in the chat box for everyone. Train yourself. Don't be afraid of making mistake. Some answer 1, some answer 3. Okay. Okay, Hassan, again. Why your answer is 1?
It's because we I don't know how to answer.
You don't know.
Yeah.
Okay. Nico, I saw you type 3. Nico, are you there?
Yes, doctor.
Yep. Could you please share with us why you type 3?
Okay. I type 3 because if you want to compare length and width, usually the length is longer than the width because this is a plate, right? So that's why I think 3 meters.
Okay. So you take 3 lah. Because length is normally longer, right?
Yeah.
Okay. I want to take one more. Who Wei Feng, Ng Wei Feng. What's your answer?
Hello, doctor. My answer is maximum value for length is 3.
So it's 3 lah, same as Nicole.
Yes.
Okay, I want to take one more. Who answer 1 just now? Siapa yang jawab 1 tadi? Let me see Photographer, Chia Zi. Teo Chia Zi. Chia Zi, you answer 1. Why? Could you please tell us?
Actually, I answer 1 just guess.
Sorry?
I'm just randomly pick out 1 number. Sorry, doctor.
So you don't know the answer?
Yeah.
You don't know why?
Yes.
You come on, you guys must be a winner. Okay, both possible? No, cannot be both possible. Okay lah, I don't have time already, so I need to proceed. Okay, guys, please read this. What is written here? Read it out. 1, 2, 3. Flow what? Parallel to plate. What does it mean? This plate, which part is parallel to the flow? Which part?
1 meter.
1 meter. So L is the length that is parallel to the flat plate. So ini soalan popular lah dalam test, dalam final. Purposely we come out with this kind of plate so that you can make mistake. Then we are happy when we mark the question. Okay, so please, be very careful when you use this formula. Okay, read carefully what are the conditions. Okay, what are the conditions? So you must be very careful lah. Okay, so this is one thing you need to take note. For plate, don't just simply take the longest. No, you need to see the condition. What is the condition? Flow is parallel, meaning the length which is parallel to the flow. That is the L. Okay, it's not the longest, not always the longest. Okay, but of course lah. Okay, of course, if you want to maximize the what do you call that, the heat transfer, you should change how you put this plate, right? Because you know H actually depends on L. Here you see the bigger the L, the bigger the Nusselt number, right? So if you are a smart engineer, okay, if you are a smart engineer, then you will change how you put. If you want to maximize the heat transfer rate of this plate, then you will change how you put this plate, right? Okay, very simple logical thinking. Okay. Okay, I guess that's all for this. Okay, the rest are, I think, basically you need to refer to the table when you solve the problem. Okay, I think I have highlighted all the main points which you need to take note when you use the formula. So the rest, I think you need to explore. Okay, you see this here, there are 3 simplified formula, right? Actually, all this, what is the purpose of this? It's actually for engineers. You see, this formula is very simple, right? 3.52 velocity divided by diameter. Okay, and it's only for air at 1 atmospheric pressure. Why we have this? Because it's very simple, right? You don't need to go and search for the raw value, the what we call that, the mu value, all this, right? It's very simple. You see, you only need to know the speed, the velocity of the air, and the diameter of your pipe. So it's very convenient. Okay, for engineers, if you go to the site or you want to estimate the H, right? For your case, you know it's air, then it's at 1 atmospheric pressure, then you know the flow velocity, you know the pipe diameter, then straight away you can estimate the H value. Meaning it's all these are actually for quick reference, right? To ease your job as an engineer. Okay, some people that develop all this. Okay, so if you want to use all this simplified formula, you must take note of the condition. All these conditions must be met. Okay, if the condition is not met, then if you use, you will still get the value. Just that the H is very far away from the correct one. Okay, so that's the purpose of why all these scientists they come up with all these simplified equation for quick reference. Okay, for quick reference. Engineer, we need to do fast, right? So sometimes all these simplified equation actually very helpful. Okay, I guess that's all for this part. For coming, okay. I want to tell you what to do after this for this weekend. Okay, it's the same thing. We don't want you to like very rush, right? Because test is coming. We want to complete test 1 before Raya. Okay, you complete your test 1, you can really enjoy the Raya, right? So we hope that now you susah sikit. Okay, you go during your weekend, you do something extra a bit. Okay, so that it will be easier for you after this. Okay, so we give you this weekend homework. Okay, basically I have explained all this formula, right? Then in this homework, actually you will see Dr. Nadia. She explained how to solve two problems. Okay, so in this video 1 and video 2, she explained step by step how to do that. Okay, so what you need to do is to go through this video. Then after that you try to solve the problem. There are 2 questions, 2A, 2-3A and 2-3B. Okay, so after you come up with this list, I think it's good for you to try all these questions, solve it, and some more Dr. Nadia explained in a very systematic way. So I think it's not that difficult. What you need to do is just follow the step, and you try to refer all those tables. Basically, it's an exercise for you. Okay, easier. Then next week we can proceed. We can do faster. Okay, so that if possible, we still can have some time for revision before test 1. Okay, that's what we plan. Okay, so for this weekend, susah sikit lah. Take some time to go through this activity, these 2 questions. Okay, is that okay for you?
Okay, Doctor.
Yep. Okay, good. I think that's all for convection. Now I now still have 20 minutes. So I want to give you feedback on your assignment 2, your answer. Okay, can you see what I'm sharing? Can you see what I'm sharing?
Now okay.
Okay. Okay, for question number 6, question number 6, group 1, I think your answer is wrong because your circuit diagram is wrong already. Group 2, your circuit diagram is also wrong, and I see that your assumption, the way how you calculate is wrong. Group 3, circuit diagram is wrong also. Group 4, wrong as well. Wrong as well. Okay. Group 5, wrong as well. Group 6, correct. Very good. Group 7, also wrong. Let me see. I don't understand why you use convection. Okay. This part 2 is wrong. Okay. Because how can it be parallel? I don't understand. Okay. And group 8, macam betul. Group 8. Air gap, lead, and lead. Circuit diagram is correct. Series. I think 8 macam betul. 6 is correct. The rest are wrong. Okay. So, I don't have time for you to present. Okay. After you present, I don't think I have time to further comment. So let me just tell you, I think maybe the way how you interpret the heat transfer is wrong, is different. Okay. So the correct way how you interpret, right, should be, let's say you see, okay, there's two scenario. One is with air gap, 3 cm. One is without air gap, right? Actually, your circuit diagram can be very simple. You see, for case number 1 with air gap, okay, you only need to draw this. You only need to draw like this. Okay, for case number 2, without air gap. Okay, very simple. This is the air gap, 3 cm. This is the lead. And this is only lead. Right? What you need to do is very difficult for me to draw. I cannot put mark. Okay, it's here. I want to mark, but I cannot mark. Okay, this is T in. We assume the water is boiling 100. This is the, so we assume here is 100, right? And here, this point, it should be actually top top of the surface of the lid. T lid surface. Or yeah, you don't need to know on also. Okay, better. Okay, let's put the point number 2 as here. That is T ambient, right? Let's put it 25 degrees Celsius. T ambient, normally we put T and infinity. Okay, 25 degrees Celsius, right? So your circuit diagram is this. Because the heat actually flow from inside to outside, right? I see why you put like this is parallel, because I think you assume heat is transferred through the wall like this. But come on, this is a vacuum flask, right? It's a vacuum flask. Vacuum means what? Means there is a layer here, right? Inner wall and outer wall, there is a layer of vacuum. Vacuum means what? No air, nothing, right? It means heat cannot be transferred through here. We know conduction, convection need a medium, right? So even the heat can be transferred possible through the wall, but the amount, the quantity is negligible, right? It's very, very small. So you don't need to actually consider heat transfer through this. Why you assume heat is transferred to the wall? No, the biggest heat transfer is through here, through the lid. Okay, that's why group 1, 2, 3, 4, 5, and 7, why you got the wrong circuit diagram? Because your assumption, the way how you see this is wrong, you interpret. Okay, then, okay, now you know. For this one, case number 1, case 1. Case 1, this case 2. Right, case 1, how many? So let's say we assume here is 100, right? Air gap. So this is the first R because of air. Then second is what? Is the lid. Right, also through conduction. Then third is, because we don't have the, if we have the temperature surface temperature, then we can, actually you can assume T surface. To make your job even easier, let's say you put here slightly hotter, 30 degrees Celsius. Okay? Then you only need to have 2, right? This is your T in. T in equals to what? 100. This is your T surface of the lid, right? Forget about the T ambient. Okay? 30 degrees Celsius. Okay? Now this one you have 2 resistances. This one, for this case, sama saja. Here is T in 100. Here, T surface. Maybe because directly get in touch, right? So this surface might be hotter. So you put T surface can be, let's say, 35 or 40, let's say, because here hot water is directly get in touch with this surface, right? So maybe 40 lah. Okay, 40. Okay, so then you calculate. So this one, you only have 1 resistance, right? So this R lid, and this is your T in 100. This is your T surface of the lid, that is 40. And then you do the calculation, you compare what is the Q. Q for case 1, what is that? Q for case 2, what is that? Then you know, right? Which one is bigger? It means the water gets cold faster. Do you get the idea? I think
yes.
the main problem is the way how you interpret this situation is wrong. You assume heat is transferred through the wall instead of here. This is the only way, actually. Cannot say only lah. The most significant amount of heat is actually being transferred through the lid, not through the wall. Okay, come on, you learned in high school, right? Thermos, that this vacuum layer causes, already minimize the heat transfer. So we assume the heat transfer through the wall is negligible. That's why you can carry your thermos without feeling hot, right? That's the reason. Okay? Apply the logical thinking you have then in solving this real life problem. Okay? Yeah, Liang Hong, you have any question?
Doctor, I have two questions here. So first thing, about the bottom of the thermoflask. So for the circuit diagram, do we need to draw out the exact circuit diagram for the bottom of the flask, because for both cases it's the same? And then number two is, do we need to do the calculation because both cases is the same?
What do you mean by bottom?
The bottom of the thermoflask. There is also a Q from the bottom of the flask, right?
There is also what?
Q, the heat transfer from the bottom of the thermoflask.
Why from the bottom?
Because it's just the conduction, right? Oh, okay. Oh, okay.
You
So
mean
the
heat is lost through the bottom?
no. Sorry, doctor. I forgot about the vacuum. So there may be only the one question now. So for solving this type of question, we just really need to like understand the logical thinking. Like very
Logical thinking is very important. I cannot say only depend on logical thinking. You also need to use the knowledge you learn in this course, right?
Doctor, how about we make an assumption, like we assume there is no vacuum.
But the situation given to you is vacuum, right? It's a thermos. Then how can you assume it is not vacuum? I don't get what you. Do you understand what I mean? Because the situation given to you is a thermos. Then we understand thermos, there is a vacuum layer, right? Between the inner wall and the outer wall.
Okay, doctor, I understand already.
Yeah. Because if you assume there's no vacuum, you are making your life more difficult. Come on now, why make your life so difficult? Then if there is no vacuum, then so many things you need to consider. Then your what? Your circuit diagram becomes very, very complicated. You got my idea, right? So
yeah, because for myself, I draw all the circuit, the things out.
Okay. That is very good for you to train your thinking, your understanding. So I would not say you are wrong. It's actually good. Okay, you are encouraged to do so. But in solving the real problem, we try to simplify. Right? We try to simplify. I will not say this is something foolish, but I think I must affirm you, Liang Hong. This is something very good because you go back to the fundamental, then you try to translate this situation into this. Then you are training yourself to think. I think this is a very good practice. Yeah, very good. But in the exam or in solving the problem, we try to simplify. Okay, we try to simplify it. You got my point, right?
Yes, doctor.
Okay, good. Thank you. Any other question before we end? Guys,
Doctor?
I have a question. Yes.
I think I have a question to ask, but then is regarding to the previous table.
Table.
Yeah, the table.
Okay.
Okay. I'm curious for the temperature. Can you scroll lower? I mean, scroll down. Yeah. So the temperature range is for the correct one is the one showing here. Is it? I mean, like for the first table.
Temperature range. Which one?
Yeah.
Which
The
temperature?
first table.
First table.
Yeah.
This one.
And
Is
then
there
I think
any
it's
temperature range?
referring. Sorry.
What do you mean by temperature range?
Okay. Because my temperature range is different from here, so is it the
Temperature
correct one?
range.
Yeah,
I
I mean
don't
the
get
first.
what you mean by temperature range.
Okay, wait. Maybe doctor, you can scroll to the first table.
First table.
Yeah.
Okay,
and then I'm referring to the temperature range for water.
Water. Okay, this one.
Yeah, and then
Right.
so this is the correct one, right? Because mine is different.
Yours is what?
Mine is wait
Mm.
mine is from 0 to 315.6 degrees Celsius.
0 to 315.6 degrees Celsius.
Yes.
Oh, really? What about the rest? Okay, because I haven't checked. I haven't checked that. I trust that you, because this copy directly from textbook, right? So I don't think you make a mistake. So I don't check. So the rest, what you get? To me, this range seems to be more logical lah. But where did you get this range?
Actually, I get this from senior work because I can't find the temperature range in textbook. I don't know why, but then yeah.
Oh, really? Chiazi,
Yes,
you
doctor.
get this? You get this
I get this from textbook.
textbook, right?
Yes.
Okay. Just now, who asked the question? Sorry.
Voon.
Sorry.
Voon.
Okay, Woon. Okay, Chao Xian. Yeah. So you can ask Chiazi. You can ask your friend which part of textbook they refer to.
Okay.
You can ask them because this range doesn't seem logical to me lah.
Okay, doctor.
Yeah, I think this range it sounds logical.
Okay.
Because this flow inside pipe, then how can you expect water at 0 degrees Celsius to flow? And okay, I think this sounds more logical to me lah.
Okay, doctor.
Okay. Yeah. Any other question? Any other question? Okay. If no, that's great. So, yeah, thank you for your involvement. And yes, please try the two exercise, the two questions during this weekend. And yeah, we'll continue coming Sunday. That's all. Have a great day. Have a great weekend.